आई होप दिख रहा है। ओके, थर्मोडायनेमिक्स। व्हाट इज थर्मोडायनेमिक्स? उससे पहले कुछ क्वेश्चंस है कि हीट फ्लोज कैसे होते हैं, हीट ट्रांसफॉर्म कैसे होते हैं, और एक कप ऑफ टी ऑटोमेटिकली हॉट से कोल्ड क्यों चलता है, ये फ्लो हॉट से कोल्ड में क्यों आता है। इसी सब्जेक्ट का स्टडी को हम लोग थर्मोडायनेमिक्स बोलते हैं। व्हाट इज थर्मोडायनेमिक्स? इट इज थर्मो एंड डायनेमिक्स। थर्मो मीन्स हीट एंड डायनेमिक्स मीन्स फ्लो। हम लोग यहाँ स्टडी करेंगे फ्लो ऑफ हीट एनर्जी। ओके, बिफोर वी मूव बिफोर वी मूव मुझे कुछ मैथमेटिकल टूल्स देखने पड़ेंगे, और वो मैथमेटिकल टूल्स कुछ ये है। मैथमेटिकल टूल्स, फर्स्ट वन, इंटीग्रेशन ऑफ e to the power minus x to x to the power n minus 1 dx. This is equal to gamma of n. Gamma, how we define the gamma? Gamma, generally we can define n minus 1 into gamma of n minus 1. Okay, if n is even, then we can write gamma of n is equal to n minus 1 factor. Okay, if gamma is even or odd, anything, but it should be integer. If n is not integer, like n is equal to 1 by 2, then gamma of 1 by 2 is equal to under root pi. Okay, under root pi. And if n is 3 by 2, then gamma of n is equal to n minus 1 into gamma n minus 1 into gamma of n minus 1. Okay, then gamma of 3 by 2 will be 3 by 2 minus 1 gamma of 3 by 2 minus 1. Okay, and 3 by 2 minus 1 is equal to 1 by 2 and gamma of 1 by 2, and we know 1 by 2, gamma of 1 by 2 is equal to under root pi, that is under root pi by 2. The next mathematical tool is integration of e to the power minus alpha x square minus infinity to infinity. So limit is minus infinity to infinity and dx. That is equal to under root pi by alpha. And again, if we have minus infinity to infinity e to the power minus alpha x square plus beta x dx, then we can write e to the power minus beta square by 4 alpha, beta square by 4 alpha into under root pi by. Okay, ये हमें याद रखने पड़ेंगे कुछ मैथमेटिकल टूल्स, इससे बार बार हम सॉल्व नहीं कर सकते। ये सॉल्वेबल है, बट अगर इसे याद रखते तो अच्छा। ठीक है, तो हम लोग देखेंगे लॉज, अबाउट लॉज ऑफ थर्मोडायनेमिक्स। लॉज ऑफ थर्मोडायनेमिक्स। ठीक है, लॉज ऑफ थर्मोडायनेमिक्स। फर्स्ट वन is zeroth laws. Okay, zeroth laws is very basic. Okay, will come later, इसके बारे में पढ़ेंगे हम लोग, लेकिन उससे पहले हम लोग फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स पढ़ते हैं। फर्स्ट फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या बोलता है? इट सिंपली gives idea of conservation of energy. Conservation of energy. Okay, हम before we define that, we have to understand about the work done. What is work done? Okay, work done, as we know, work done is equal to, as we know, work done is equal to, work done is equal to force into distance. But in thermodynamics, we study about the gases. Okay, we deal with the parameters pressure, volume, pressure and volume. So uh, corresponding of the force here, we can assume the pressure here. Okay, and about displacement, corresponding of displacement, we study here about the volume. Okay, then work done is equal to P dot ds, sorry, P dot d. Okay, this is the work. Okay, let's go with some graph. This is p axis and this is v axis. Okay, and your process is like this. This is the initial point, this is the initial point, that is p1 and v1. In this state, our pressure is p1 and volume is v1, and in this state our pressure is p2 and volume is v2. Then we can write about the work done. What is work done? Work done is equal to p dot dv. Okay, p dot dv means it is the area covered by the curve. This area is the work done. Okay, this area is the work done. What will be the area here? This is delta v. Okay, this is delta v, and it is like a triangle. Okay, it is like the triangle. This triangle plus this rectangular form is the area of this covered area. Okay, as it is p2, hmm, it is p2, it is p2 and it is p1, p1 and p2. For a triangle, we write half into base into height, base into height. Here base is delta v, that is equal to v2 minus v1. and height is delta P. Okay, delta P is P2 minus, or we can write P2 minus P1, P2 minus P1, but here it is mod of 2. Okay, so we can write, half into delta volume means delta V, that is V2 minus V1, and pressure, that is P2 minus P1. Okay, this is the area of this triangle part. And we will talk about the pressure, means this rectangular part. Then we can write the area of this rectangular part is height into base, and base we know that is delta V, and height is P2. Then area of this rectangular part is P2 into V2 minus V1. Then total area is equal to, total area is uh, area of rectangular plus area of triangle. Area of triangle is half into V2 minus V1 into P2 minus P1. Okay, plus P2 into V2 minus V1. This is the area, total area, and this is the work done of this process. Now, can you say this work done is positive or negative? Positive or negative? Negative means decreasing of decreasing of volume. Decreasing of volume means delta V is negative, and positive work done means increasing of volume. Okay, means delta V is positive. Okay, then you can see this is the initial volume V1, and this is the final volume V2, and here volume is increasing. This process direction is like this. Okay, so delta V is positive. Delta V is positive. So this work done is positive. Okay, positive work done. What does it mean? Positive work done का मतलब क्या? Positive work done means work done. Work is done by the system. How you can say it? Work done is work done by the system. Work done by the system is a positive work. Okay. Work done by the system. Okay. Work done by the system. Work done by the system means, let we have a container like this. मेरे पास एक कंटेनर है जिसमें गैस मॉलिक्यूल्स. Okay. And this is the piston. This is the piston. It is movable. Okay. Means volume can increase or decrease. Okay. If this system is working on this piston, then this piston will move upward. Upward, this piston will move forward. Then the change of volume is positive. Change of volume is the positive. This work is done by the system, not by me. If अगर इसमें हम वर्क कर रहे होते, ठीक है, हम वर्क कर रहे होते, तो क्या होता कि मैं इस सिस्टम को इस पिस्टन को प्रेस कर रहा हूँ. अगर मैं इस सिस्टम को प्रेस कर रहा हूँ तो ये वर्क डन मेरे तरफ से किया गया, तो इसका जो वॉल्यूम होगा वो डिक्रीज होगा. मीन्स डेल्टा वॉल्यूम, डेल्टा वी इज नेगेटिव. दैट इज वर्क इज डन बाय मी. ओके, ये वर्क मुझे. So this is the concept of work done by the system and by us to the system. Okay, we can use the right word, that is to the system. Work is done to the system. Work is done to the system. Okay. Okay. After one more concept is there, that is internal energy. Okay. What is internal energy? Let we have a container and filled with gas. Gas may have kinetic energy. Okay. Or this may have potential energy. Okay. What does mean by the potential energy and kinetic? Okay. Kinetic energy always be there because these molecules or these particles are moving in the content. Okay. That means it have the kinetic energy, and this system have some energy, that is the energy of the system. Energy of the system. एनर्जी ऑफ द सिस्टम, इसका मतलब ये है कि एनर्जी ऑफ द सिस्टम मीन्स इंटरनल एनर्जी. Internal energy. Okay, this is internal energy. This internal energy is equal to kinetic energy of all particles. Okay, and plus potential energy of all particles. Okay, potential energy of all particles. Here potential means interaction. Okay, interaction means कोई पार्टिकल जिसके पास अट्रैक्शन या रिपल्सन का प्रॉपर्टीज होते हैं, दीज आर द इंट्रैक्शन. दिस ये पार्टिकल्स एक दूसरे पार्टिकल के साथ वो क्या करेंगे, इंटरेक्ट करेंगे. मतलब या उसे रिपल करेंगे या फिर उसे क्या बोलते हैं, या फिर उसे अट्रैक्ट करेंगे. ठीक है. तो इन आइडियल गैस we neglect this potential energy. Sorry, potential energy means interactions. Okay, there is interactions, but we neglect it in the ideal case. Okay, ideal gas like helium, there is also some interactions, but we neglect it. Okay, in ideal gas we neglect these interactions. Means all kinetic energies is equal to internal energy of the system is sum of all kinetic energy. Okay, this internal energy we can write like u, kinetic, sum of all kinetic energies. Okay, kinetic energy, kinetic energy depend on, it is directly proportional to the velocity square of the velocity. Means kinetic energy, as we know, kinetic energy is equal to half mv square, and this velocity also depends on temperature. The increasing or decreasing of the velocity, it will depend on the temperature here. Temperature, if we will increase the temperature, if we increase the temperature, then velocity of the molecules or velocity of the particles will increase. Okay, this is the means, what does it mean? If internal energy is directly proportional to kinetic energy, then it is also directly proportional to velocity. Okay, and we know here velocity is depend on the temperature. That means internal energy also depends on the temperature. Okay, uh, means u is equal to cv dt. T is the delta t. Okay, u is directly proportional to dt. ओके, अब एक कॉन्सेप्ट पे आते हैं, दैट इज स्टेट फंक्शन. What does it mean? State function is a function which depend on the initial point and the final point. Let this process P and B. This is P and this is volume X. Let any process occurs. Okay, initial to final. That is P1, B1 initial point, and that is P2, P2 and P2. That is initial point and the final point. This P2 V2 is the final point, and this process is like this. Okay. And this state function do not depend on path. Okay, state function do not depend on path, do not depend on path, and it depends only on initial point and final initial point and final point. Okay, it only depend on the initial point and final point. What are the parameters or what are the physical observables that that is state function? Okay, एक्सेप्ट ईयर में इसमें जितना भी वर्क डन रहेगा और हीट एनर्जी एक्सेप्ट दिस टू ऑल आर स्टेट फंक्शन, all are state function except this. Okay, these are not state function, these are path function. मतलब यहाँ जितना भी पढ़ेंगे थर्मोडायनेमिक्स में, तो जितना भी पढ़ेंगे वर्क डन और हीट एनर्जी को छोड़ के सारे फंक्शंस सारे ऑब्जर्वेबल्स क्या होंगे? स्टेट फंक्शन. लाइक यू मीन्स इंटरनल एनर्जी, V volume and pressure, these are all state functions. And what is path function? Okay, path function is a function which depends on path, okay, the function which depends on path is the path function. Like work done depends on path, and Q also depends on path. Okay, let we have a process whose initial point is P1 V1 and final point is P2 V2. This is P axis and this is V axis. We have three different paths. Okay, this is path 1, this is path 2, and this is path 3. Okay, come about the work done. What will be the work done of path? What will be the work done of path 2? And what will be the work done of path 3? Okay, work done means the area covered by the curve. Okay, area. For first, we can say this is the area covered. Okay, this is the area covered by the first curve. that is work done 1. This is W. And for work done 2, this is the area covered by the path or curve. Okay. This is work 2. And again for work 3, this will be the area of work 3. So area covered by the work done 1. Let me change the color. Okay. Area covered by the work done 1 is more than work W1 is higher. And second one, the area covered by the second curve is more than work done of 2 is more. But it is less than W. So you can arrange this one. This work done 1 is greater than work done 2, and this work done 2 is greater than work done 3. Okay, that means it depends on path. अगर हमारे पास ये कर्व है और 3 डिफरेंट कर्व, तो ये वर्क डन डिपेंड करता है कि वो कौन सा पाथ चूज कर रहा है. मीन इट डो नॉट डिपेंड ऑन द फाइनल एंड इनिशियल पॉइंट like the path function, because it is not the path function. Okay, that means work done is not a path function. Sorry, work done is a path function and it is not a state function. Okay, okay. Instead, after that we come to cyclic process. Some process. Hmm. Cyclic process. What is cyclic process? If any process that start from a point, एक पॉइंट से स्टार्ट करते हैं और वो प्रोसेस उसी पॉइंट पे खत्म भी होता है. ओके, दिस प्रोसेस इज कॉल्ड साइक्लिक प्रोसेस. ओके, दिस प्रोसेस इज कॉल्ड साइक्लिक प्रोसेस. ओके, in this process if we will talk about the state function, अगर इस प्रोसेस में हम एक स्टेट फंक्शन का बात करते हैं लाइक यू इंटरनल लैंग्वेज. ओके, तो स्टेट फंक्शन क्या बोलता है? स्टेट फंक्शन सेज दैट it only depends on initial and final point. Here initial point and final point is the same. Okay. Means there is no change in the state function. Means change in energy will be 0. Change in internal energy will be 0. But what about the path function? Path function क्या बोलता है? Path function says that it do not depend on initial and final point, but it depends on path of the process. Path of the process. Okay. This one is P1 V1, but this area covered, and this area covered is the work done of this process. Okay. This is called path function. And this in cyclic process, all the state function change in the state function will be 0. Okay, let's come to the another process, that is isochoric process. Isochoric process. Isochoric process means change in volume is equal to the process जहाँ पे change of volume will be 0, means V1 is equal to V2, means final volume is equal to initial volume. There will be no change in the volume. Okay, let this is V and this is P. Then how it works? The process, the curve is like because here V is V is constant. Okay, V is constant. Then what will be the work done? As we know, work done is P dot dV. If dV is 0, then the work done is 0. If the process is isocoric, प्रोसेस अगर आइसोकोरिक तो इसका वर्क डन भी हम लोग का 0 होगा. Always work done is equal to 0. There will be no work. Now another process is adiabatic process. Okay. What is adiabatic process? Adiabatic process says that delta Q is 0. Delta, what is delta Q and what is Q? Q is applied energy or change in energy, change in heat energy. Uh, Q is heat energy. Let me say एक कंटेनर है इसमें बहुत सारे मॉलिक्यूल्स गैस and here delta Q will be 0, means we are not applying any heat energy, we are not giving any heat energy, or no heat energy is extracted from this container. No heat energy can move from this container to outside of the container. Okay. मतलब कोई भी क्यू बाहर ना बाहर आ सकता है, ना क्यू अंदर जा सकता है. कोई भी हीट एनर्जी ना हम लोग अप्लाई कर सकते हैं, ना उससे कोई हीट एनर्जी बाहर आ सकता है. दिस इज द एडियाबेटिक प्रोसेस. डेल्टा क्यू विल बी 0. Okay. This is adiabatic process. In this process, the equation will be P V to the power gamma is equal to constant. That means initial is P1 V1 and final is P2 V2. Final point is P2 V2. Then P1 V1 to the power gamma is equal to constant, and that is again equal to P2 V to the power gamma. What is gamma? Gamma says that it is monoatomic, diatomic, or triatomic, anything. And gamma is Cp by Cv. Okay. What is Cp here? Cp is heat specific heat capacity. Specific heat capacity in constant pressure. Okay. And Cv is specific heat capacity in constant volume. इस पे बात करते हैं. बट ये जान लो कि ये एक स्पेसिफिक हीट कैपेसिटी है, और Cp means specific heat capacity at constant pressure, and Cv is the specific heat capacitor capacity in the constant volume. Okay. Cp by Cv. and CV is equal to F by 2 into R. Here F, what is F? F is degree of freedom. Okay, and R is the gas constant. Okay, R is the gas constant and F is the degree of freedom. What is degree of freedom? Okay, let's assume there is one particle you can say, or one point particle. इसके पास 3 dimensions है, x, y, and z. Then there will be a kinetic energy of translation kinetic energy. Translation kinetic energy will three different directions. Okay, 3 different directions. Means degree of freedom is 3. If we say that is diatomic like okay, then it have translational kinetic energy as well as it have rotational kinetic energy. Translation kinetic energy, it will have different directions, 3 different directions, that is kx, ky, and kg. But in rotational direction, rotational degree of freedom, it can move only two ways, this one and this one. Means like this is a diagonal molecules. It can move like this, and this is x, and another way is xy plane. Okay. Then we can say there is a 3 degree freedom in translation kinetic energy, and there is way two way of rotation, means 2 degree of freedom in rotational kinetic energy. Okay. Then total degree of freedom will be 2, 3 plus 2, that is equal to 5. That means CV, what will be the value of CV? CV is equal to 5 by 2R. Okay. Then what will be the relation of CP and CV? Okay. CP minus CV in ideal gas. Okay. We are talking about the ideal gas. CP minus CV is equal to R. Okay. Then CP is equal to R plus CV, and that is R plus F by 2R. So Cp is R into 1 plus F by 2. Okay. Then Cp by Cv is equal to R into 1 plus F by 2 divided by R into F by 2. We have 1 plus F by 2 by F by 2, that is equal to gamma. Now, what will be the work done in adiabatic process? Okay, let's see the work done. Work done means P dV, and as we know, P v to the power gamma is equal to constant. So P is equal to K by v to the power gamma. So we can write work done is equal to K by v to the power gamma into dV. Okay. Then What is the integration of this? V to the power minus gamma into V. That is equal to K into V to the power minus gamma plus 1 divided by 1 minus gamma initial to final, and that is equal to K into K by 1 minus gamma into V2 V2 1 minus gamma minus B1 1 minus gamma. Then we can write this K by 1 minus gamma into V2 by V2 gamma minus V1 by V1 gamma. Then again it is V2 to P2 by V2 gamma into, write like this, V1 V1 to the power gamma P1 by P2, and we know V1 to the power gamma into P1 is equal to constant. That means K by 1 minus gamma into 1 by K of V, and that is equal to V2 to the power gamma into P2. Right? V2 P2 minus V1 P1. Okay. This K will cancel out, and that is equal to 1 by 1 minus gamma into V2 P2 minus V1 P1. Again, we know in ideal gas V1, or you say in ideal gas PV is equal to RT. Actually this is nRT, and we are taking here n is equal to 1 molecules. Okay, so we can write here this is RT2 and this is RT1. Okay, so we can write the work done is equal to 1 by 1 minus gamma into R into T2 minus T1, R by 1 minus gamma T2 minus. This is very important to say. I realize this. Okay. This is the work done of adiabatic process. Next process is isothermal process. What is isothermal process? What is isothermal process? The process in which delta T is 0, means T is constant. During the whole process, temperature is always constant. Okay, any process occurs from one point to another point, that is P1 V1 and P2 V2. Okay, in this process temperature delta T will be 0, means T1 is equal to T, delta T will be 0. Then what will the work done of that process? Okay, work done means P to D. In ideal gas equation is PV is equal to nRT. Then what is P? P is equal to nRT by T. Okay. Then work done will be nRT by P into T. That is the integration. Okay. Here all are constant. N is constant, R is constant, and T is constant. Why T is constant? T is constant because this process is isothermal. Okay. So we can write nRT 1 by P dV. What will the integration of that? nRT ln V from V1 to V2. So we can write nRT ln V2 minus ln V1 by using property of logarithm. We can say ln V2 by. So work done is equal to nRT ln V2. It depends on change on the value. This is the work done of isothermal process. So okay, ओके that is there. आगे हम लोग पढ़ेंगे फ्री एक्सपेंशन, थर्मोडायनेमिक कोफिशिएंट के बारे में और बहुत सारी चीज़ें और लॉज ऑफ थर्मोडायनेमिक्स. ओके ओके लेट्स एंजॉय. थैंक यू.